Um, in this video, we're going to look at how we're going to calculate the internal resistance of the battery. I took a question from a national paper, and obviously this will assist us in terms of answering exam questions, right? And then let's see what we're given here. So we're given that in the circuit diagram below, the reading on ammeter A is 0.2 amps. Battery has an EMF of 9 volts and an internal resistance R. So they gave us the ammeter reading to be 0.2, and then the internal resistance is unknown, but also we're given the EMF, right? So that will obviously drive us to the first question, where they want us to calculate the current through the 5.5 ohm resistor for 3 marks, right? So what we know is that the current in the 11 ohms resistor is 0.2 amps because it's given by the ammeter reading here. And then the current in the 5.5 ohm resistor, it's unknown, right? So we need to ask ourselves, what are the quantities that we need in order to calculate the current, the 5.5 ohm resistor, right? So we realize that we need to know the potential difference, or what is commonly known as the voltage. So if we decide to use for 8.2.1, if we decide to use the formula V equals to IR to calculate the current, we realize that we're in short of the V. So before we get the I, we need to get the V first. And what we see is that the 11 ohm resistor and the 5.5 ohm resistor are connected in parallel. Therefore, the voltage or the potential difference in the 11 ohms resistor and the potential difference in the 5.5 ohm resistor will be equal, because remember, voltage is the same in parallel. So we're going to get the voltage of the 11 ohms resistor by using the formula V equals to IR. And then the current in the 11 ohm resistor we know is 0.2. And then the resistance is 11, right? And that will give us the voltage across that resistor. The voltage across the resistor will be given by 2.2 volts. So we must not forget that this is the voltage across the 11 ohms resistor. But because of the parallel connection, the voltage across the 5.5 ohm resistor will also be 2.2 volts, because voltage is the same. So now we will be able to calculate the voltage. We will be able to calculate the current in the 5.5 ohm resistor. And then the current will be given by I equals to V over R. Then the V will be 2.2, and the resistance will be 5.5. And this will give us the current. The current is equals to 0.4 amps. So we know that now the current that is passing through the 5.5 ohm resistor is 0.4 amps, right? And the one that is passing through the 11 ohms resistor is 0.2 amps. So we have got the current of the parallel branches. And then now, in this question, which is the main question, they want us to calculate the internal resistance of the battery, right? So we must get small letter r, right? So if we're asked about the internal resistance, obviously the first formula that comes to mind is E equals to I times capital letter R plus small letter r. This is the EMF formula, right? So obviously in this formula, we need to know the total current of the circuit, and also we need to know the total resistance of the circuit, which is the total external resistance. This is the resistance of everything that is outside the battery. So we have the 11 ohms resistor that is connected in series, and also the 11 ohms resistor that is connected in parallel to the 5.5 ohm resistor. So these three resistors, all of them, they're going to give us the total external resistance, which is the capital letter R. So we'll start by getting the total external resistance, which is the capital letter R. Obviously, we must first consolidate the ones that are in parallel. We must get the total of the parallel first. And we can simply use RP equals to R1 times R2 over R1 plus R2. And then this will be equals to 11 times 5.5 over 11 plus 5.5. So this will give us the total resistance of the resistors that are connected in parallel. So this is what you must know always, that in order for you to get the total resistance of the circuit, you must make sure that you get the total of the parallel first, so that you can add it with the ones that are connected in series. And this will give us an answer of 3.67 ohms. This is the total resistance of the parallel connection. And after getting the total resistance of the parallel connection, the R total, which is the total external resistance of the circuit, which is related to the capital letter R in the EMF formula, will be given by 11 plus 3.67, and this will give us 14.67 ohms. So now we know that the total external resistance of the circuit is 14.67, which is the capital letter R in the EMF formula, right? So now that we're done with the total external resistance, we need to get the total current of the circuit, which is the capital letter I. So the total current of the circuit will be given by the 0.2, so this is the I, will be 0.2, that is in the 11 ohms resistor, plus the 0.4, that is in the 5.5 resistor, and this will give us 0.6 amps. So this will give us the total current of the circuit, because this current that we're talking about, it got divided when it reached to this point, right? The other current went up and the other one went down. So the 0.2 went up, the 0.4 went down, right? But this was the current that was coming from the battery, and then it separated at that loop. So this will be the total current of the circuit, which is 0.6. So now that we have got the total current of the circuit, which is 0.6, we've got the total external resistance of 14.67, and we are given the EMF, which is 9 volt. We will be able to calculate the internal resistance. So now we're going to write the EMF formula. EMF equals to I times capital letter R plus small letter r. EMF is 9 volts. The total current of the circuit is 0.6. And then the total external resistance of the circuit is 14.67 plus small letter r. That is what we're trying to look for. And then now we're going to divide both sides by 0.6, 9 by 0.6, and then we're going to get 15 equals to 14.67 plus small letter r. Therefore, the small letter r will be given by 15 minus 14.67, and that will give us 0.33 ohms. So that is how we get the internal resistance of the battery, right? So you must make sure that you've got the total external resistance and also the total current of the circuit. I hope you also enjoyed this video, and I hope it will also assist you to prepare for your prelims and also for the upcoming final examination. Don't forget to like, share, subscribe to our YouTube channel. Thanks.